Okay, so June 2013, this is paper 2PR. There you go. Question 1 is radioactivity, which is measured in becquerels. So becquerel is 1 count per second. Okay, so that's a measure of activity. Yeah, the activity of a radioactive source. Half-life, that would be measured in seconds. Radiation, what does that mean? Frequency is the closest of those distractors because that's measured per second, but activity is counts per second, which is the becquerel. The mass number of 4, well, let's just think about what each of these things. An X-ray is part of the electromagnetic spectrum, so it's an electromagnetic wave. So waves don't have mass, so it can't be an X-ray. And gamma ray is same as an X-ray, it's part of the electromagnetic spectrum, and again, consequently can't have any mass. Beta particles, they're electrons, and electrons have got a mass of 1 over 8,000, 1 over 1,860 of relative atomic mass unit, so not that one either. So it must be an alpha particle. Okay, that's the correct answer, and it's because alpha particles are made out of 2 neutrons and 2 protons. Well, there we go. We've already answered that one for ourselves, haven't we? With what we discussed in the previous question, that's a beta particle is the same as an electron. It's actually a high energy electron, which means it's moving very fast. The most ionizing is an alpha particle. Now, if we think about the alpha particle, then that's 2 neutrons and 2 protons. So this means that it's got a mass of 4 and it's got a charge of +2. It's a helium nucleus, isn't it? The +2 charge means that if it crashes into any atoms, it's very good at ripping off the electrons from it. So that makes it highly ionizing. And the 4 mass, again, is very massive. So when it collides with stuff, it's carrying a lot of energy. Again, it can rip off the electrons from neutral atoms quite easily. If you compare that to a gamma ray's got no mass and it's got no charge, so that's very weakly ionizing by comparison. That's the end of question 1.